Hello everyone, I am Shankar. In this video, I would like to discuss the detailed solutions of control systems questions given in GATE 2024 paper, and this is from instrumentation paper. Now the first question is, this is 1 mark question. In my lectures, it is from chapter 4, frequency response chapter. The sinusoidal transfer function corresponding to the polar plot shown in the figure for t greater than 0 is. Now, if you just recollect the polar plot of, suppose g of s is equal to 1 plus ts. So, for this particular transfer function, the polar plot can be when omega is equal to 0, the real part is 1. When omega is increasing from 0 to infinity, the polar plot will move in vertically upward. In the similar way, the real part is the same 1. When the frequency is increasing towards infinity, the plot will come down to bottom. This could be the transfer function for 1 minus j omega t. Therefore, option C will be the correct answer for the question. Now, let us move to next question. This is also 1 mark question. It is a little bit lengthy. Consider the state space representation of a system x dot is equal to ax plus bu, where x is state vector, u is the input. A is the system matrix and B is the input matrix. This is a common statement. Choose the matrix A from the following options such that the system has pole at the origin. Therefore, now from the state space equations, how can you find system poles? Poles is equal to roots of characteristic equation. What is characteristic equation? Si minus A is equal to 0. So here you should select one characteristic equation in such, you should select one system matrix A in such a way that the characteristic equation has a roots, at least one root at origin. Okay. Now, suppose for option A, if I check Si minus A determinant, you will get S minus 1 minus 1.5. I hope you can follow this 2 by 2 matrix, minus 2 and S plus 3 is equal to 0. Okay. Therefore, it will give you S square plus minus 2s or plus 2s minus 6. Okay. Plus 2s, it will be minus 3 and a minus 3. So, it will give you minus 6 is equal to 0. The roots of these characteristic equation 1.645 and minus 3.645. Okay. So, in these roots, there is no pole at the origin. Next, for option B, if you check Si minus A determinant, this will come around S minus 1, 2 and S minus 3 is equal to 0. Okay. Then what is the equation you have? S square minus 3s plus 3 is equal to 0. And for this equation, the roots of this characteristic equation are this will be minus 3 plus 2. So, it will be plus 2, I guess. So, this is a plus 2. Therefore, the roots are 1 comma 2. Next. So, here also there is no pole at the origin. Next one. For option C, by checking determinant Si minus A, what you will get? S minus 1, 1.5, 2, S minus 3 is equal to 0. Okay. Then it will give you S square minus 4s plus 3 minus 3, hence 3 cancel, is equal to 0. Then the roots will be s is equal to 0 and 2. S is s square or s minus 4, okay, 0 and 4, right? Therefore, in this case, there is a pole at the origin. We got the required answer. So, you need not to go for option D because it is a simply MCQ. Only one answer will be correct answer. Next, let us move to the next question. This question is from time response analysis chapter. Consider a feedback control system shown in the figure. The steady state error is defined as ESS is equal to limit t tends to infinity r of t minus y of t due to unit step reference r of t is. So, what is the question here? You should find out steady state error for unit step input. So, what is mentioned? So, first let us find out what is the closed loop transfer function y of s divided by r of s, that is 1 by s into s plus 1 divided by 1 plus k by s into s plus 1. Now, in this case 1 by s square plus s plus k. Therefore, then y of s is equal to r of s divided by s square plus s plus k. Now, what is steady state error definition given? Limit t tends to infinity r of t minus y of t. Okay. Therefore, in the Laplace domain or S domain, how can you write this? Limit s tends to 0 by using final value theorem, s into r of s minus y of s. This will be limit s tends to 0, s into r of s, it is given unit step reference. Therefore, r of s will be 1 by s minus s into r of s is 1 by s divided by s square plus s plus k. So, you can cancel this s here, then it will be remaining with 1 minus 1 by k. Therefore, k minus 1 divided by k. K minus 1 divided by k. That is the answer for question 3. Option A. Next one, another 2 marks question. Consider a unity negative feedback system with its open loop pole 0 map as shown in the figure. If the point s is equal to j alpha, where alpha is greater than 0, lies on the root locus, then the value of alpha is. Now, this problem is from stability chapter, that is a third chapter in my lectures. By using Routh's method, you can find out. Now, from the given open loop plot, we can define the transfer function, open loop transfer function as, because negative feedback system means open loop transfer function and forward transfer function both are same. Therefore, it can be k by s into s plus 1 into s plus 4. This is the open loop transfer function. Next, what is characteristic equation? Characteristic equation is 1 plus g of s is equal to 0, then it will be s into s square plus 5s plus 4 plus k is equal to 0, or s cube plus 5s square plus 4s plus k is equal to 0. Okay. Then what you have to do, let us define Routh's table. Let us define Routh's table. So, s cube elements 1 and 4, s square elements 5 and k, s power 1 elements 20 minus k divided by 5, and s power 0 element, it is k. Now, in order to have this root locus diagram located on j omega axis, there should be even polynomial as a common factor. So, that is possible when you have row of 0 appeared at s power 1. This is true when k is equal to 20. In that case, auxiliary equation can be 5s square plus k is equal to 0, or 5s square plus 20 is equal to 0, then s square is equal to minus 4, or s is equal to plus or minus j2. So, it is mentioned that alpha value is greater than 0, therefore, alpha is equal to 2 here, okay, because it is mentioned s is equal to j alpha is on the root locus diagram, and hence alpha value is equal to 2. 2 is the answer for the question. Now, let us look into next question. It's a very easy question, even though I don't know why it is given for 2 marks. The transfer function of a system is g of s is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. Choose the range of zeta and omega n from the following options such that the poles lie on the shaded region of s plane as shown in the figure. Now, the only twist in this problem is this angle is given 120 degree, therefore, you have to take this angle theta. So, zeta is equal to cos theta. When this angle is 120 degree, theta will be 60 degree. Therefore, zeta is equal to 1 by 2. Next, in the shaded region, theta is less than 60 degree. Hence, damping ratio could be greater than, of course, or equal to 1 by 2. Okay. So, in the shaded region, you can take it like this: theta is less than or equal to 60 degree, hence zeta is greater than or equal to 1 by 2, and this particular phasor distance will be omega n is equal to 2. Therefore, in the shaded region, omega n definitely greater than 2, and hence option B is the correct answer. So, these are the questions. I hope total 8 marks came from this instrumentation paper, control system subject. So, these are the questions from GATE 2024 control systems instrumentation paper. So, I am working as a faculty at Home Institute. We will offer coachings for GATE as well as AE exams for various PSUs. If you are interested, you can visit our website or call the phone number given on this slide. Thank you for watching, and if you not yet subscribed my YouTube channel, please subscribe and spread a word with your friends and other relatives also. My YouTube channel is for purely educational purpose. Thank you for watching.